Hello guys, how you doing? What's up? So guys, I'm just going to continue going over number 75. If you recall, it was basically proving that this distribution right here is approximately normal. So just to reread that, just refresh everyone's memory. There was a video that I posted before about with the Google Meet. The third one actually started this problem, but now that we can like kind of take more time, let me just go and read the problem right here. All right, so Consumer Reports magazine collected data on the usable capacity in cubic feet of a sample of 36 side-by-side refrigerators. Here are the data. And there's 36 right here, and we're talking about cubic feet of basically the volume of refrigerator, the capacity. All right, so no problem. A histogram of the data and summary statistics are shown here. And this distribution of refrigerator capacity is approximately normal. Justify your answer based on the graph and the 68, 95, 99.7 rule. All right, so you can see, first of all, like the first part of the answer is pretty easy. You can see that the histogram right here does appear to be approximately normal. Okay, it looks like a single peak between 16 and 17. But it's approximately, looks approximately normal. All right, so step 2 right here. We're going to say right here, now we have to go and base it off the 68, 95, 99.7 rule. That's a little tough. And just to refresh your memory, what does that mean? That means 68% of your data is within one standard deviation of the mean. So 68% of your data is right here, plus one standard deviation and minus one standard deviation. 95% of your data is within two standard deviations of your mean. So 95% is going to be going all the way out to here, and all the way out to here is 95% of your data. And 99.7% of your data is going to be all the way over to the right and to the left, 3 standard deviations to the right, 3 standard deviations to the left. Okay, so what does that mean specifically? Well, we have a mean of 15.825. And we have a standard deviation of 1.217. Okay, so let's see here. So there's our mean, and there's our standard deviation, okay? So first of all, the 68% of your data is right here going to be between 15.825 plus 1.217 and 15.825 minus 1.217. Obviously, the minus is what we do first because that's going to be on the left-hand side if you're thinking of this like a number line. 15.825 minus 1.217 is 14.608. 17 and 15.825 plus 1.217 is 17.042. All right, so what we're trying to think about right here, just think about like a number line, right? Let's say we have a whole number line right here. All right, we have right here 14.608, and we have right here 17.042. We want to figure out how many values are in between 14.628 and 17.042. And is that, once we figure out how many are in between, is that 68% of our data? So what did we do? We figure out how many values are between and divide it by the total. Okay, so let's take a look right here. So the amount of values in between right here, let's do it. Between 14.608 and 17.042. 14.6 and 17.042. All right, so let's see here. So when I originally told you before, 14.608, all right, it would start actually right here. This is 14.6. And then 17.042, okay, it would stop right there. That's 17.00. This is 17.20. So this is, again, 14.608, 17.042. Axel, can you turn that down a little bit since you're not here? Okay. All right, so let's see here. All right, so we're going in between. We're going to count right here. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. So we have 24 values right here, and it's a total of, remember, the n is 36, so 24 over 36. And that's going to end up being right here 66.7%. Ends up as 0.667. And that comes out to 66.7% of the data, or 66% of the, you can say of the data or of the values are within one standard deviation. Okay? All right, let's look at the next guy. The next one we're talking about 95%, and that's between 13.391 and 18.259. All right, let's look now. 13.391 and 18.259. All right, so 13.39 is about 13.4, right? So let's see, 13.391, so that's the cutoff there, and 18.259 is about right there, 18.259. There's the cutoff there. Okay, so what do we have here? Well, we have everything but this guy and this guy, but everything else is here. So this is going to be 36 minus 2 is 34 values. So this is going to be right here, 34 values. Okay, so what we're going to do, we'll come over here. All right, we're doing, again, how many over our total. So this is going to be 34 over 36. All right, 34 over 36 gives me approximately 94.4%. Okay, comes out to 94.4%. Yes, I should have done two squiggly lines here because we are approximating, right? It's not exact. Okay, next, right here. I bet the next one is going to be all of our data, but let's see for sure. 12.174 to 19.476. So this right here is covering right here. This is the 99.7% right here. And this is the 3 standard deviations. So remember what we did. We took the original mean right there and then added 3 times the standard deviation, which is 1.217, and then subtract 3 times the standard deviation, 1.217. And that gave us 12.174 to 19.476. All right, so let's take a look here. 12.174, 19.476. Yeah, so that right here, 12.174 would be on the outside. 19.476 is also right there going to be the outside. So I was right. It's actually, in this particular case, 100% is everything, right? It's going to be right here. This represents 36 of 36 values, which gives me 100%. Okay, so right here, we could just say here that our final answer is, remember what they're asking right here, just make sure you do. Is this distribution of refrigerator capacities approximately normal? So I'm just going to say, the distribution of refrigerator capacities is approximately normal based on the empirical rule. Okay. And you could just put, if you want to, in parentheses to back that up. That's, of course, right here. The we're talking about the 68, 95, 99.7 rule. Okay. This, combined with the bell-shaped graph, gives good evidence that the distribution is approximately normal. bell-shaped graph or bell-shaped histogram. Gives good evidence that the distribution is approximately normal. Oops. And it's always important in your answers to have some type of context, like what are we even talking about? Don't make it too generic. So right here, we're talking about refrigerator capacities, okay? You could have even had in, we were talking about volume right here, but I think this is actually fine how we actually just put it. We were talking about volume in cubic feet, but right here, this is fine right here. Okay, so this gives you good, this is a good answer right here, and we already backed it up with the work right here, that's above, so the work plus the little explanation is good answer right here. Okay, thank you very much, guys.